Good day everyone. Our presentation is all about dynamic programming, a problem-solving technique that efficiently finds optimal solutions by breaking problems into smaller, overlapping subproblems and storing the results to avoid redundant computations. And there are two main approaches to dynamic programming. The first one is the forward recursion approach, which builds solutions iteratively from the base cases. And the second one is the backward recursion approach, which starts from the final state and works backward. So in this presentation, we apply dynamic programming to solve a route optimization problem using the backward and forward recursion approach. So our case or problem is Kent is currently at Gaisano Grand Mall searching for a new pair of shoes but didn't find any style he liked. So he decided to visit Gaisano Town Mall to explore their shoe collection. So the possible routes for Gaisano Grand Mall to Gaisano Town Mall are shown in the diagram below. So here is the possible route for from Gaisano Grand Mall to Gaisano Town Mall. So, using dynamic programming, find the shortest path from Gaisano Grand Mall to Gaisano Town Mall, helping Kent find his desired shoes efficiently, given that the map shows all possible routes and their distances. And Kent must start at Gaisano Grand Mall and end at Gaisano Town Mall. So, our solution is first, draw the network diagram, indicate the corresponding distances, and then divide it into stages. So, here is our network diagram. And then next, find the optimal solution using the backward recursion approach. Here. So we start from M, where the cost is 0, and then calculate the shortest path backward. And then after that, the value of f of L is 300, as you can see in our network diagram. And then the f of k is 79 because the distance from K to L is 79. Since we already have the value of f of L as 300, then we add them together. Then when we calculate f of j, the process is still the same. We take the value from the previous path, f of k, which is 79, and then since we already have the distance from j to k, we add it together to get the result. So if there are two or more possible paths, we need to find the minimum distance and then choose the smallest one. So we simply solve it step by step, and then we select the shortest distance at each stage, and then repeat the process until we reach the starting point. That's it. And then so in this part, we calculate the total distance for each possible route from node A, which is the starting point, to node M, which is the destination. So the first one is A to B to D to G to K to L and then to M. So you can see here. So the total distance is calculated by summing up the distances along the path. So A is 1,401 plus 1,272 plus 667, and then plus 500 plus 379 plus 300, and then total of 4,519. Then followed by A to B to D to G to L, and then to M. Then same goes with the first one, just add them, and then you can see the total of 4,140. Okay, and then the same method applies to the other possible routes. So you can calculate the total distance by summing up the values along each path, and then you determine which one has the shortest distance. So the objective here is to find the shortest total distance among these possible routes. So the shortest path, as you can see here, the shortest path is A to B to D to G to L, and then to M, with a total distance of 4,140. So this is the optimal solution determined using the backward recursion approach. Here, you can actually see here. So this concludes my part of the discussion on dynamic programming and the backward recursion approach. So for the next one, Memoration will verify our results using the forward recursion approach.
Next, find the optimal solution using forward recursion approach. Current location, stage 1A, possibilities, path A to B, the distance of 129 and the total of 129. Stage B, possibilities, path B to D and B to C. The distance of B to D is 605 and the distance of B to C is 3. So the total of distance of B to D is 129 plus 605 equals 734. And the total distance of B to C is 129 plus 3 equals 132. Stage 3, C, possibilities, path C to E and C to F. Distance of C to E is 471 and the distance of C to F is 486. So the total distance of C to E is 132 plus 471 equals 603. And the total of distance of C to F is 132 plus 486 equals 618. Stage 4, D, E, F. Possibilities, path D, DJ, ED, AH, FE, FI. So the distance of D to G is 167, the distance of A to D is 150, and the distance of A to H is 190, and the distance of F to E is 120, and the distance of F to I is 120. So the total of distance of D to G is 734 plus 167 equals 901. And the total distance of A to D is 603 plus 150 equals 753. And the total of distance of A to H is 603 plus 190 equals 793. And the total distance of A to F to E is 618 plus 120 equals 738. And the total distance of F to I is 600 18 plus 120 equals 738. Stage 5, JHI. Possibilities path J to L, J to K, H to G, H to G, I to H, I to J. So the distance of J to L is 200 and the distance of J to K is 157 and the distance of H to G is 149 and the distance of H to G is 150 and the distance of I to H is 155 and the distance of I to G is 329. So the total distance of J to L is 901 plus 200 equals 1101 and the distance of J to K is 901 plus 157 equals 1058 and the distance of H to G is 793 plus 149 equals 942 and the total of distance of H to G is 793 plus 150 equals 943 and the total distance of I to H is 738 plus 155 equals 893 and the total distance of I to G is 738 plus 329 equals 1067. And the next is stage 6, J and K. Possibilities for J to K and K to L. So the distance of J to K is 121 and the distance of K to L is 79. So the total distance of J to K is 943 plus 121 equals 1064. And the total of distance of K to L is 1058 plus 79 is 1137. And the last is stage 7 L. Possibilities for L to M is the distance is 300 and the total distance of 1101 plus 300 equals 1400. So therefore our optimal solution is A, B, D, J, L, M. Conclusion. By utilizing the forward, backward, and recursion approach, Kent was able to systematically analyze and compare possible routes between Gaisano Grand and Gaisano Town. This method allowed him to break down the problems into smaller sub-problems, ensure that both immediate and a long-term routes decision were considered for optimal efficiency. Through this structured evaluate, he identified routes A, B, D, J, L, M as the most optimal path, potentially minimizing travel time, distance, of course.